Everybody, in this next set of videos, we're going to really continue working with algebra and trig combined together. And we're going to talk about the sum and difference formulas. So the title of our next set of videos is Sum and Difference Formulas. I got a little ambitious and wrote the first section up top by accident. So these will be the sum and difference formulas that we're going to look at. The first one we're going to look at is the cosine of the difference of two angles. Now, I'll let you read through your text to see the proof for all of this. I want to jump right into the examples, but if you're interested, feel free to check that out, or you can even Google the proof and it will run through the steps for you. So here we're looking at the cosine of the difference, in this case, of two angles. And the formula for it is cosine of the first angle times cosine of the second angle plus sine of the first angle times sine of second angle. Now I did put that multiplication symbol in here. I will note that a lot of times it's not written in, so just be careful there. I think it's easier to see if I put it in, but if you see it without the multiplication symbol, it means the same thing. So how can this be useful? It's really helpful in finding exact values of angles that maybe we're not as familiar with, but we do know similar values too. So for instance, let's find the exact value of cosine of 15 degrees. Well, one thing you can note here is that the cosine of 15 degrees is the same thing as the cosine of 60 degrees minus 45 degrees. Right? I think we can all agree that 60 minus 45 is 15. Now, the reason we chose 60 and 45 is because we know cosine and sine for these common angles, right? We typically know 0, 30, 45, 60, 90, and so on. Those are the main ones that we know and that you should know at this point. If you don't know, take out your little cheat card with all those values on it and keep it handy for you. So when you use these formulas, you really want to find the angles that you know and see if you can get it to work. So that's why we chose 60 and 45 and not something different. So in this case, our alpha is the 60 and our beta is the 45. So I'm just going to use the formula. So this becomes cosine of 60 degrees times cosine of 45 degrees plus sine of 60 degrees times sine of 45 degrees. Now, cosine of 60 degrees is 1/2, and cosine of 45 degrees is root 2 over 2. And then sine of 60 degrees is root 3 over 2, and sine of 45 degrees is also root 2 over 2. And again, these are values you should know. You have these values in your notes already. So if you haven't yet, again, make yourself a little cheat sheet, or you can even probably print it off online of those key values that we use all the time. So I'm going to do a little bit of multiplying here. 1 times root 2 is just root 2. 2 times 2 is 4. Here, root 3 times root 2 is root 6, also over 4. So what I do is I can, and a plus sign there. So I can go ahead and simplify a little bit. So I have root 2 plus root 6 all over 4. And there's nothing I can really do besides this. Root 2 doesn't break down. Root 6 doesn't break down into anything helpful either that I can simplify. So this is my final answer. We're able to go the other way as well. I will say that you can check your answers here. So if you're not sure, you just take out my calculator. I want to make sure I'm in degree mode here because I'm using degrees. There we go. So if I type in cosine of 15, I get this, obviously, which is not exact, right? That would be the decimal approximation. And then I can type in my final answer. Just be careful here. I'm going to put parentheses around the numerator, square root of 2 plus square root of 6. And then I'm going to divide that by 4, and you can see I get the same decimal approximation. So it is the same answer, but that's a good way to check if you're not sure you did the algebra right, to go ahead and use your calculator at the end to verify. Now we can also use the formula backwards. Right, so we're going to do cosine of 80 degrees times cosine of 20 degrees plus sine of 80 degrees and sine of 20 degrees. Now, just be careful. I check the formula. It does match, right? If you look at the difference formula, you can see that I have cosine, cosine, sine, sine, plus sine in the middle. And also the angles match, right? Your alpha is 80 in both cases, and your beta is 20 degrees in both cases. So I'm getting the right side of the formula here, so I can reverse it back to the left. So this is cosine of, so again, this is our alpha, this is our beta. So it's going to be 80 minus 20, which is just 60 degrees. Now, cosine of 60 degrees, again, that's something you should know. That's going to be 1/2. So we're able to use the formula in both directions here. I would probably say that the first example is more common, but if you happen to have that right side, you can revert backwards as well. So they're both good techniques to have. Now, I do want to do one more example here. And this time we're going to kind of combine what we were doing the last set of videos with verifying identities. So let's verify the identity cosine alpha minus beta over sine alpha multiplied by cosine beta equals cotangent alpha plus tangent beta. So this is the identity we want to verify. And again, you can start on either side. I'm going to start on the left side. That one looks a little bit more complicated. And I also know the formula for the cosine of the difference of two angles. So I'm going to go with that. And we're going to see if we can get to the right side. So again, this section is about, or this first part is about the cosine of the difference of two angles. So I'm going to definitely use that here as part of my simplification process. So it's going to be cosine of alpha, cosine of beta, plus sine alpha, sine beta, all over sine alpha, cosine beta there, right? Now what I can do next, I'm trying to look here. I don't really see too much I can do, but I do see a plus sign in the numerator, so I can split this into two fractions. Remember, we can't split apart the denominator, but we can split apart if the numerator has a plus or minus. So this becomes cosine alpha cosine beta over sine alpha cosine beta plus sine alpha sine beta over the same denominator, sine alpha cosine beta. And now I can actually do a little bit of cleaning up here. So I do see that cosine beta cancels, and sine alpha cancels. And I'm left with cosine of alpha or sine of alpha plus sine of beta over cosine of beta. Now, if I think here, cosine over sine is cotangent. So this becomes cotangent of alpha, and sine over cosine is tangent, so that becomes tangent of beta. Just watch your angles there. Obviously, we're not using all the same symbol. These would be two different angles theoretically. So cotangent alpha plus tangent beta, that's what we were trying to get to. So we are done.